I want to make a video about the complete alignment of a CNC turning center. The reason that I want to make this video is that when I first purchased a CNC lathe, I was looking for some kind of complete guide to help a person bring in a used machine that had been abused back to the original factory alignment specifications. Now, all this information is available from various sources, mostly from threads on practicalmachinist.com. However, I have not seen a complete guide start to finish, and especially I have not seen it in a video form. So this is the video that I wished I could have found when I was first getting into the CNC world. So, disclaimer, I'm not a representative of Bridgeport Romy. I have no factory training from any manufacturer. I'm not certified in any way. Any information that you obtain from this video is purely for entertainment. There are just too many different variables, too many kinds of machines, too many kinds of people working on those machines to try to cover everything. And by no means is this a definitive guide, but I think it will be helpful for people who are, in the same position where they have an older machine. Maybe it's not turning, or it is turning a taper, or the parts are not parting correctly, or not drilling on center, drilling oversize, braking tools. All of those things can often be caused by a problem with the machine alignment. So if you're experiencing any of those problems, or you just want to check your machine for your own curiosity, I think this will be a helpful guide. So the reason that this machine is easy to level is that the capacity of this machine is 8-inch diameter by 20-inch length. That's pretty standard for a 2-axis turning center. This is a very common size. I would say almost any CNC machine shop of any size has had a lathe about like this machine at some point in its history. This is kind of the starting point for a turning center. Now, like I said, this machine, 8-inch diameter, 20-inch length. This machine weighs about 9,000 pounds. It is hell for stout. Now we'll set it down on the pads and check the twist in the Z-axis ways, and we'll see how it looks, but my hunch is that there's going to be very little twist. It won't take much to get it out. This machine only has 2 axes, no live tools, nothing crazy. Now contrast that to this manual engine lathe that you see. That's a 16 by 40 engine lathe. It has a capacity of what it says, 16-inch diameter over the ways. I think it will turn about 10-inch diameter over the cross slide by 40-inch length. That machine weighs maybe 3,000 pounds. When you pick up one of the, turn one of the leveling screws, it's going to go wherever it wants. It's very flexible. It's hard to level that kind of machine. You could spend hours getting the twist out of a floppy machine like that. Heavy turning center like this, not going to be a problem. Some of the larger machines, long bed CNC lathes, flat bed CNC lathes that have pedestals or longer ways, a lot more involved in leveling those machines. But this machine is going to be pretty easy. Also, most of the work that's done on these kind of machines is chucking work. It does have a tailstock, but in my experience, chucking work is a lot more common. Some machines that have tailstocks, they're never used. Even I worked in a place that had Okuma LB45 machines with 24-inch chucks. We never used the tailstocks. We actually took them off and threw them away. So because of that, and the leveling will be pretty straightforward. So I'm going to go ahead and set the machine down off the skates onto some pads. The only caution that I will give before you set the machine down is to make sure that you have run the leveling screws down far enough that the machine will be at the correct height to slide the coolant tank under. Or if you have a conveyor, same rules apply. Pretty simple, just need to make some measurements. This machine has small pads that need to go underneath the leveling feet. They're 15 millimeters thick. Real simple. The other thing that I'll say is that you should always try to set up the leveling feet in such a way that when you go to level the machine, you're turning the leveling screws counterclockwise or backing them off. Now this machine's not so bad. It has 7 leveling screws and it weighs about 9,000 pounds. If you turn the leveling screws clockwise, you can lift this machine. It's not a big deal. However, I've worked on larger machines in the 40 to 60,000 pound range. There's no way that you can turn those leveling screws clockwise with anything less than about a 36-inch long bar and have any chance of raising the machine. In that case, you almost always have to jack the machine up, turn the screw, set the machine back down onto the pad, and then level it again, turning the screw counterclockwise. I've not personally seen anyone strip the threads on the leveling screws, but I think it could be a possibility, especially because some people like to chain down the machine using the leveling screws, and yeah, putting a chain over the threads on the leveling screw is a really bad idea. I have personally spent hours with a thread file trying to fix, divots and other damage in leveling screws because riggers or truck drivers have used the leveling screws as a tie down. So if anybody's watching this and thinking about moving their CNC machine, do not use the leveling screws as tie downs, please. For the sake of anyone who has to come after you, don't do it. Okay, I've got the machine sitting down on the pads. It's sitting on 3 feet right now. Basically the 2 underneath the chuck and then 1 at the tailstock end. And when I come back in the morning, I'm going to find someplace on the machine that is flat and use that to set the rough level of the machine. By rough level, I mean actually leveling the machine so that all the drip trays will run back and there won't be any major issues, and so it doesn't look off level. The human eye can detect things being off level very sensitive just by eye, so we want it to look level. So by the way, I know that there are probably going to be some pedantic viewers who will point out that there's no reason for the machine to actually be level. That is correct. Leveling is a term of industry that basically means to take the twist out of the ways and make them all parallel and perpendicular as required, and flat, by the way. There is not any specific reason to have the machine level other than, like I said, sometimes there are drip trays or channels for oil or coolant to run. Back to collecting points. If the machine's extremely out of level, you can get the flow in the wrong direction, or there will be more of a tendency for chips to build up and block the flow. Just to give an example, recently I had to install a large Moristiki lathe, and this machine had to be set on anchors and aligned to a bar feeding system for large pipes. And the bar feeding system was basically fixed, and the floor anchors were basically fixed. We had about, I don't know, maybe 10 millimeters of adjustment in the hold down screws. So in order to actually align the spindle center line to the bar loading system, we just tipped the machine forward slightly. And there's no reason that you can't do that. That machine didn't have any drip trays that ran front to back on the machine. So other than, maybe just some perception that the machine's slightly out of level, there's no effect on the performance of the machine. So yeah, it doesn't have to be level, but it does have to be, level in quotation marks. By the way, I didn't film setting down the machine. Nothing too exciting there. But the skates that I had the machine sitting on are right here. These are the Hillman roller style skates, or tank style skates, caterpillar style skates, whatever you want to call them. And I know people don't like them because they're dangerous, and they're quite correct. They are very dangerous if you don't use them correctly. The biggest problem with these skates is that they always come in a set of 4 for some reason that I have never understood. There is almost no situation I can think of where it's advisable to use 4 skates. Don't do that. Use 3 skates. And in this case, I actually always try to connect the skates together. There's probably a more elegant way to do it, but all I'm using here is a piece of black pipe and some small cant twist clamps. And that's all you need. The problem with these skates is that they don't track straight. They don't have a lot of traction on the floor, and if you don't do something like this to keep the skates from twisting, that's what they'll do. They'll turn sideways and basically walk themselves right out from underneath the machine. But I've been using a system like this, where I connect them together with various lengths of pipe or steel bars, and I've never had an issue. And I've moved machines up to 20,000 pounds that way, almost always by myself. So they are dangerous, but if you put your mind to it, you can come up with a way to make them a lot safer. Okay, we're looking at the headstock end of the lathe. I took the outside cover off, and usually this is the best place to find some kind of horizontal planar surface that you can use to set the rough level of the machine. Almost always there's a boss for a lifting eye, or a pad that was used as a datum when the casting was originally machined that's going to be horizontal, and all you need to do is find that and figure out a way to set up your level. In this case, I don't know if you can see it in this frame, but underneath the lube tank on the bottom left side of the screen, there is a datum surface, and we'll take a closer look. So this is the lube tank. Underneath the lube tank right here you can see these 2 pads. I just scraped the paint off of those 2 surfaces, and you can see the machining marks. That's definitely a machined surface that they used probably in the original setup of the casting. So all we need to do is set up our level on those 2 surfaces. I'm just going to use a hard jaw from a Kurt Weiss. And that'll bridge across those 2 surfaces. And then I'm actually going to use this little Starrett pocket level. I don't think there's any reason to use the precision level. This is just a rough leveling of the machine. The precision level is so sensitive that you could just drive yourself crazy trying to get the machine rough level using a ultra precision level. So we're just going to use this little pocket level, and we'll check the machine front to back and end to end, and get the level as close as we can with this little pocket level. Like I said, there's really no reason for the machine to truly be level other than just drainage. Okay, so there's the bubble on the level. Obviously the bubble is going to be towards the high side of the machine, so we want to lower the screw that is in the direction of the bubble. You can see it's pretty darn close already, and I didn't do anything you know, off camera. This is how the level looked when I set it down on the machine. So I'll see if I can get that a little bit better. Okay, I think that's it. Okay, it looks like the tailstock end is probably high. But it's a bit of an optical illusion. So I think I'll take the tailstock end down just a bit and see if it gets any better. Okay, I think that's it. It's hard to see on the camera, but the bubble looks pretty well centered to me. Okay, we are ready to level the machine. So, where do you start? I mean, how do you actually level the machine? So the best place to start is in the manual. And most machine tool levels will have a section about leveling the machine. However, most of them are almost completely worthless, and this one is basically no exception. I'm sure you can't read what it says, but I will paraphrase. And this is basically translated from what I would assume is originally Portuguese, quite poorly, I'll add. But it basically says transversal leveling readings must be equal between themselves, and longitudinal readings must also be equal between themselves. So it says for perfect leveling, check. Use 2 precision levels graduated at 0.02 millimeters per meter or 0.2 per foot, assuring that the level difference is smaller than 0.04 millimeters or 0.005 for the transverse and longitudinal leveling. So basically what it's saying is we need to have a twist in the ways less than 0.005 over the length of the ways, and they recommend using 2 levels. Yeah, we're not going to do it that way, but that's okay. So what we're going to do is put away this lovely manual. It's pretty much worthless. We're going to use this level right here and this bracket. Now this bracket is just a piece of 2-inch square tubing, got a hole in it. All we're going to do is find something on the machine that we can put a screw through. Usually there's something on the turret, you know, doesn't have to be the size of this hole, could be a lot smaller, could even be bigger. We can drill this out. We'll find something. It's just a generic bracket, and this level here is accurate to 0.005 over 10 inches. That's about twice the tolerance that the manual suggests, but I've personally never seen a level that I could afford that was accurate to 0.2 over a foot. Yeah, that's a pretty accurate level. This one will be more than adequate. This is a 12-inch long level. It's made in Poland by Viz. You can buy these online, $75. Nothing to it. I've leveled dozens of machines with this setup right here. Never had an issue. The only thing that I'll say is that you do need to calibrate your level. That's very simple. You just need a level surface. Set the level on the surface. center the vial, flip the level 180 degrees, center the vial again. Eventually you should get an equilibrium where the vial stays centered from one side to the other. I'm not going to show you how to do that. I'm sure you can find 4 hours of video footage from Tom Lipton about that procedure. Go look it up. No need to cover that here. So we're going to move over to the machine and find a suitable surface to mount this level. Okay, this is the turret. The machine's powered on, so it's probably going to be a little bit harder to hear what I'm saying. There's a cover here over the front of the turret, and I would try to use one of these screws here, but I pulled one out and I don't think it's going to work. So we're just going to take that cover completely off. It's got to come off anyway, so might as well do it now. Okay, so now I can see a row of bolts along the outside. I'm certain that these bolts are for the curved coupling, so we'll just pop one of those out, and that should work fine for the mounting of our leveling bracket. Okay, I didn't have the right hardware to use the turret cap screw. But there's a plug here that I took out, and there's a 12mm tapped hole right here, so that will work. Okay, we'll do a little tweaking and get the machine homed out, reposition the camera, and we should be ready to check the twist in the Z-axis ways. Okay, I got you set up over top of the level. This is at the extreme positive Z. I'm just going to jog the machine in Z minus, and we'll watch the bubble. I haven't done anything to the machine as far as leveling. It's still sitting on the same 3 points, 2 underneath the chuck and 1 under the tailstock. Okay, I hope you can see that. I know the light probably washed the bubble out. It's a little bumpy ride. I don't know if this machine has continuous jog. I had to use the hand wheel. But basically you can see that without doing anything, it looks pretty much perfect to me. And that's not surprising. Like I said before, this is a relatively short travel machine that is very heavily built. So we are going to leave everything just like it is and move on to the next step. So normally with the machine like this, in order to take the twist out, we would use 4 points. I typically use 2 underneath the chuck and 2 underneath the tailstock. And start with those 4 points, adjust them as needed in order to get the twist to 0. In this case, we got very lucky and the twist is already at 0, sitting on 3 points. So now the question is, what do we do with the other pads that are not touching? And the answer is that we're just going to bring them to bearing. And that means a lot of different things to a lot of different people. And the only way that I know to quantify bearing is to use an indicator. So you can see I've got a dial indicator set up next to the leveling screw that I'm working with. I've got it zeroed out, and basically all we're going to do is run this leveling screw down so that it contacts the steel pad, and we're just going to wait for the needle on the indicator to twitch. And as soon as it twitches, we know that we're bearing. We don't need to crank down on it any more than that. It's not necessary for all the feet to have equal loading. We just want them all to be bearing some weight. That's really all there is to it. We're going to go ahead, bring all the remaining screws to bearing. Then we're going to go back to the machine and check the level again. It's possible that we could throw the machine out of level just from this procedure. So we always want to double check our results after we make any kind of adjustment. So we're going to bring this one down. These leveling screws are use a 30mm hex. In my experience, that's the most common size. If you don't have a 30mm, 1 3/16 will work just fine, but that's not a very common size. I happen to have one, but I don't think you'll find it very often. But 30mm, that's what you need. Okay, I just felt it contact the pad. There, I can see the needle move. That's it. Okay, one more time. I'm on the next leveling pad. I'll see if I can do a close-up of the dial indicator. There. So this is a 1/1000th indicator. You can see I moved the needle approximately 1/1000th, or 1/1000th. That's plenty. We're gonna stop there and move on to the next pad. Okay, let's double check our results. Well, that looks pretty good to me. We may have moved, I don't know, just a tiny fraction of 1 graduation on the bubble. Certainly is good enough for what we're doing with this machine. Let's move on to the next step.